Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Imran bin Abdul Sufyan. My matrix number is 241091173. Today I would like to presenting the lab 2, which is the topic is operational amplifier. So I will presenting the part A, C and E. So I would like to start it. This is the circuit of part A, which is we use the sine source. The sine is 0, 1 and 1000. Resistor 3 is 1000. We use the LM741, and resistor 4 is 3.3K. So I will.
My name is Muhammad Shafta Iman and my matric number is 241091223. So right here we have a non-inverting amplifier circuit. So the component that we have is OPM at M741 that we use, and we have the R1 is our resistor, and R2 is also a resistor. Also we have over here is sine, the sine over here that we already set up in 0, 1 and 1000 itself. And also we will have a ground, and you can see over here we will have a voltage input of 15 volt, and we have two over here. In fact, one is V2 and V3. Going to jump to simulation waveform over here. Okay, so this is our waveform that we already get. So as you can see on the top side or the green side is our V out. As you can see, it's already the same. And the bottom side, if it will become a V in. So as you can see, we will get the top of the 1 volt as set by the input source. I'm going to use a cursor over here. We're going to measure it, and we can see it become about 1 volt. So I'm gonna resume on the V out or our green waveform over here. So as you can see, we're going to check on it. We're going to measure all the same on the top side of it, or peak of our waveform over here, and we will get approximately about 11 volt that we're going to get. On this phase, the signal is in the phase with the input, and the positive peak and the negative true occur at the same time. Why this is, we have this shape, is a clean sine wave, indicating no clipping or distortion, as the 11 volt peak is safely below our 15 volt power supply rails that we already put inside of our circuit over here. So in this circuit, I will give my verdict or my summary. The amplification, the input signal is amplified by the factor of 11. Although the non-inverting, the output is in the phase with the input. Okay, the operation, the OPM is operating correctly within its linear range. That's all for our parts on this non-inverting amplifier circuit. I will pass it to my colleague over here.
This is the circuit for the C. We use pulse 1, -1, 0, 0.01 micro, 0.01 micro, 0.5 milli and 1 milli. For this, this is for this C. For the part C, we use the integrator. So I would like to run it. Okay, I will do it step by step. I started with VN 002. Okay, for the VN, we start with 1 volt and ending with -1. For the V out, for the V out, we start with 808.28 millivolt and peak to 1.311 volt.
Okay, we are going to resume our explanation on differentiator amplifier circuit over here. So as you can see, the component that we have over here is pulse. On the V side itself, we use the independent voltage source for the V1. For the pulse, V1, V2, time delay, T rise for in this, and initially 0, von 1, time delay is 0.0 U over here, T rise will be 0.0005, and the P4 also the same, T on will be 0, time period will be 0.001. Okay, we will resume. For this circuit, what we have here is resistor 1K, RF over here is 100K, RS is 1K. Okay, we will use the same OPM, which is LM741. We will go to our sine wave over here. W1, we'll put the cursor, we'll here, check any cycle, it is okay. The output waveform over here consists on the sharp voltage spike over here. As you can see, this is very sharp spike, which is a positive spike because it is rise from 0 and go down back to 0. From 0 to 1 volt during the positive phase. We occur the falling edge on the negative slope of the input square wave. Since the output is inverted, a negative rate of change will result in a positive output spike. For the negative spike occur during the rising edge, or the positive slope in the input square wave, a positive rate of change, which is dV in over dt bigger than 0. The result is negative output spike. The 0 output when the input voltage is constant, the flat high or flat low portion of the square wave over here. As you can see, square wave, you put the cursor over here. Again, over here, the voltage is constant, the flat high on the low portion of the square wave. The rate change is 0 over here. So, in the range, I'm going to change to 0. So, the output voltage is 0. Output over here. So, you can see over here is 0. The output itself is 0. So, the triangular appearance in the output spike shown in the simulation is not idle impulse, because they infinitely the thin spike but have finite width and appear somewhat triangular due to practical non-idle nature of the OPM and stabilizing the component in the circuit. The cursor will already shown approximately around 2.3 here, 2.3 volt. 0.3 volt. Therefore, the differential circuit, over here we have the act of the edge detector producing a momentary voltage proportional to the speed and directional of the input voltage change.
This is the circuit that I built it, and I would like to run it. Also, I will do the step by step. I'm adding the plot. For this, I use VIN. Okay, starting with at 0 volt and peak to 999.04 millivolt. And I put the V out starting with negative 32.83 millivolt and peak to 5.998 volt. That's all for me. Thank you.